Hello, my name is Beth Dixon, and I am the Math Lab Coordinator, and I work in room 222 of the Math and Behavioral Social Science building. And it is my job to help students with their math courses here at Walter State. And today I want to do the beginning lesson of factoring. And we're going to start with factoring by looking at the greatest common factor. And the greatest common factor is that factor that every term of your expression shares. And we're going to start out by looking at our 2x plus 10. And when we look at 2x plus 10, we'll see that both of these expressions share a common factor of 2. Now, we're going to think, but not write, 2 times x and 10 we're going to think of as 2 times 5. Now, I'm going to be writing these thinking steps because I'm on camera and you're sitting in front of a computer. So the way that I'm going to show you via this media that what's going on is to write a lot of things down that you're not going to normally write. So I'm going to be writing this extra step. But this is our thinking step. This is what we're thinking and processing. We're thinking that both of these share this 2. So because they share that 2, we can write that 2 out front and write what's left, which is that x and that 5. And it shares, and we're going to keep that plus sign, x plus 5. Because what we've done is rewrite this using our distributive property, because we can multiply this back 2 times x and get the 2x, and multiply 2 times 5 and we get the 10. And that would be our checking process. And it would check to give us back what we started with, and that means that we've done this correctly. And so you see that factoring is to write an expression in 2 factors that multiply to give us back what we start with. And we want to fact out the greatest common factor of every term. And in this case, that was the 2. And again, we're thinking this step. We're not going to write it. Now, as you start, if it helps you to write this step that we're thinking, that's fine. But most of you will probably not want to write it and won't need to write it. Now, as we look into the next group and next problem, let's look and see what they share as a common factor. When we're looking for common factors, we want to look for both numbers and variables that each and every term share. So as we start here, let's first look for numbers. We've got the number 10, the number 5, and the number 25. So we can see that they all share the number 5. Then we want to look at variables. X to the third, x squared, and an x. Well, it looks like they all share an x. So our common factor is that 5x. So we can see that 5x times something would give me back 10x to the third. Well, 5 times 2 would give me 10. And if I take away 1x, that means I must have 2 left over. Because remember, when we multiply, we add exponents. Because 5x times 2x squared gives me that 10x to the third. So what goes down here is the 2x squared, because that's the shared part, and that's the part that would be the other part. This is the common factor, and this is the part that's left over. And again, this is what we're thinking so that we get the 2x squared. For the next part, the 5x is the shared part. What do we need to multiply back to get the x squared? We have the 5 and the x. We just need one additional x. So all we need is that minus sign, because we're not going to be changing any of our signs, and then the x. We will change some signs a little bit later, but not right now. Okay, then plus, and then the 5x. Well, what do we need to multiply 5 by to get 25? 5. How do we figure that out? 5 goes into 25 5 times. And we already have the 1x. 5x times 25x times 5 gives me 25x. So as we look at this, there's the 5x, there's the 5x, there's the 5x. That's the common factor. And out here we need that plus 5. 5x times 2x squared gives me 10x to the third. 5x times minus x gives me 5x squared. 5x times 5 gives me 25x. Okay, let's look at the next one. These two share a 3, because 3 will divide into both of those, and they share an x. 3 goes into 6 2 times, and we take out 1x. That leaves us 1 inside, because 3x times 2x would give me back 6x squared. 3 goes into 3 one time, and we take out the x, because if I multiply 3x times 1, I'll get the minus 3x. Notice we do need something here. We have to put the 1 there, because without that, we only get the first term. So when we take out the full factor there, we'll get a 1, because when a number divides into itself, we get a 1. And remember, that's really kind of what we're doing with factoring, is it's a division process to rewrite something as its factors. Okay, let's look at 2 more examples here. Let's look at this one right here. And as we look at this one, we can see that they share a 3. They share an x, but we want to take out the greatest common factor. And we have a power to 4, we have a power to 3, and we have a power to 2. Well, the greatest common factor is not going to be to the x to the 4th, because I cannot take out 4x's here, and I can't take out 4x's here. My greatest common factor can't be x to the 3rd, because I can't take, although I can take out 3 here, I can't take in 3 here. This 2x squared can only share 2 x's. So 2 is the highest I can share, because the smallest one is the only one that determines, I'm stuttering there, so excuse me, but it's the smallest power that determines the greatest common factor. Okay, notice I paused. Let me say that again. It's the smallest power of your variable that determines the greatest common factor, because it's the one that can give everything but can't give something it doesn't have. So in this case, x squared is my greatest common factor, because I can take 2 x's out of x to the 4th, and I'll leave 2. 3 goes into 6 2 times. And again, if we need to write it down, 3x squared and 2x squared multiply to give me 6x to the 4th, because that's the thinking step that we're doing. What multiplies together to give me that 6x to the 4th? 3 goes into 6 2 times. X squared divides into x to the 4th and leaves me x squared. And then we can divide that 3x squared into x to the 3rd, and it just leaves me the x. Because the 3 goes into 3 and leaves me that understood 1 that I can either leave or write. Then I can say, divide x squared into x to the 3rd, and that leaves me x to the 1st power that I can either leave or write. Now 3 goes into 9 3 times, and it takes out both of those, so I'm done. And again, I can write that step up here, because this is what I'm thinking. Okay, let's look at this last one. X squared minus 4. With x squared minus 4, do they have a common factor? Well, they don't share a number, and they don't share a variable. So there is not a greatest common factor, which we often abbreviate GCF. So there's not a greatest common factor. We could put a 1 in front of it to show that they share a 1. Notice nothing inside changes, because when we factor out a 1, nothing changes. And we'll use that fact on later factoring. And actually, this does factor using something else. Just not a technique that we've talked about quite yet. So you have to listen to parts 2, 3, and 4 to figure out how to factor this one. But it doesn't have a greatest common factor, which is the lesson today. And so we're through with the first step, which is always in factoring. The very first step of every factoring problem is to check for that greatest common factor. So this is the lesson on the greatest common factor. It's not a complete lesson, but just a short review on finding the greatest common factor. If you need some additional help on finding the greatest common factor, come and see us in MBS 222 at any time. I hope this helped. Thank you.